This is an example of where you could use inequalities in a real life situation. So Carmen has up to $15 to buy seeds. Vegetable seeds cost $1.50 and flower seeds cost $2. Can she actually buy stuff? Yes. What could she buy? Give me an example of something possible.
Vegetable seeds and flower seeds.
You could buy one of each, right? And still have money left over. Could she buy 5 of each?
No.
No. Then she wouldn't have enough money. So she has options. Does she want to grow more vegetables? Does she want to grow more flowers? She has some options, but she only has $15. Okay? So, first of all, we can write an inequality. We can choose a variable for each thing.
17 grand.
Okay? Sometimes people like using x's and y's. Sometimes people choose different variables. Like, they might choose v for vegetable and f for flower. Okay? I'm going to just stick with x and y. I'm going to just make vegetables x and flowers y. Okay? How do we write this into an inequality? Well, if x is the number of vegetable seeds packages that she buys, it's going to cost her $1.50 times however many she buys. And it's going to cost her $2 times however many of the flower seeds she buys. And this total has to be less than or equal to 15. Question?
No, that's
Oh, okay. Yeah. So if x is the number of vegetable seeds that she buys and y is the number of flower seeds that she buys, 1.5 times x is how much that's going to cost. 2 times y is how much that's going to cost. And it has to be less than or equal to $15.
There should not be an equal to sign because in part B it says she has to have change from the $15.
In part D, but right now she can spend up to $15, which she could spend 15. It is possible that she has no change from this. So here's our inequality in part A. Right? Can you give me a possibility that works?
10x.
10x? She just buys vegetable. Zero flowers. She's not going to be very happy, but be very well fed. That'll cost exactly $15. Another possibility.
So 2x and 6y.
2 vegetable and 6 flowers. This will cost 12. This will cost 3. That also is perfectly $15. Does she have to spend all her money? Right? Right? Maybe Carmen has given $15 by her mom. Mom says, go buy vegetable seeds and flower seeds. And she comes back only with 1 package of each and keeps the change. And lies to her mother that they were very expensive this year. This is all we could get. That would be another possibility. All right. Well, we just had to find 2 possible ways you can spend up to 15. Can Carmen buy 5 vegetable seeds and 4 flower seeds? How much would that cost? 5 vegetables would be 5 times $1.50 plus 4 times $2. $15.50. So the one answer is no, right? Unless Carmen's like 7 years old, she could use the 7-year-old factor. She goes to the till and brings this up and puts $15 down, and it comes up at $15.50. Do you think there's a chance the person would say that's okay? You
No,
can-
no.
No, not now. Well, now they have like the computer systems, like I can't actually figure out the button to push to make this work for you. But in the olden days when people were nice, not like now, right?
Less greedy.
Less greedy. Maybe that person who's the nice old man or old lady working at the seed store would be like, you go home and take these to your mom.
If
That'd be
she's
so
7, you
nice.
should charge her extra.
Charge her extra. Nowadays, 7 years old, perfect. Probably doesn't know math. I can take advantage. No,
That's smart.
that's smart.
You're not cheating, you're not trying.
Wow. There are people that really hope you don't learn your math well so they can take advantage of you and take your money.
Can I get the varsity girls down here in the office at the break, please? So varsity girls volleyball team down at the office at the break. Thanks.
Okay, so in D, she still needs to have change. Can she spend $14.50?
Yes.
How? How can she spend, if she still needs to get change and spends $14.50, how is that possible?
Flowers, 3 vegetables.
5 times 2 and 3 times $1.50. Excellent. She could spend $14.50. I'm going to add a part E, because I think I've added one like this on your test. We are going to graph this. The graph is weird. Okay? So first of all, we're going to graph this situation. And it's not as simple as just graphing the line and shading it. Okay, so our equation was 1.5x plus 2y has to be less than or equal to 15. 2y equals negative 1.5x plus 15. Divide everything by 2, and you would have negative 3/4 x plus 15 over 2. We're going to graph this. It has a y-intercept of 7.5. There we go. Y-intercept of 7.5. I could plug in, well, we could take some of the points that we've already found. She could buy 10 vegetable seeds. Vegetable seeds were our x, right? We have this point, 10 comma 0. That made exactly 15. What was our other one that made exactly 15? 2 and 6. And we could draw the line. And it's a solid line. I don't have to go about and erase it. Now, normally, if you were shading, would you shade above or below?
Below.
You would normally shade below. But in this question, shading below doesn't completely make sense. Because shading below says everything works, including this point right here. She goes and buys negative 1 vegetable seeds and negative 1 flower seeds. You can buy negative 1 of something. She also can't go and say, I'm just going to buy half. Rip open the package, throws away it comes to the counter with half a package. Try to do that. Okay, go to Dollarama and say, I only want to buy half a chocolate bar. I left the other, just come to the till with half the chocolate bar and say, I left the other half on the shelf for somebody else. See how that goes over.
I've tried that.
You'll try that.
No,
Okay.
I've tried that.
We'll see. I'm afraid I might lose my job if this gets out that you're trying this because of my suggestion. Okay? So when we go to graph this, not only do we draw the line, but the only solution is just the dots that would fall, like if I actually drew the grid lines,
Yeah.
your solution is just the dots on the grid lines. No. And so if on a test, I would give you it with the grid lines and you would just fill in the dots. And of course, all of these ones would exist, right? Because you could buy, right? So the graph of this is a little bit tricky. First of all, because you can only have whole numbers. Second of all, you can't have negative numbers. That would be wonderful if negative numbers. I go to stores all the time. And I'd be like, I'd like to buy -7 TVs. And they'd be like, great, we owe you $14,000. Okay. And then I'd leave the store. What'd you do today? I bought -7 TVs. Why'd you do that? I made $14,000. Life is good. And I go back to the store and say, I'd just like to buy one TV with the $14,000 you gave me. Okay.
But you will need to give them the TV.
Yeah, I would have to give them TVs, right, if I bought -7 TVs. Yeah, there's a problem here. Okay, questions to circle on this one? 11 and 15. No.